everyone. I just sneak into the morning. It's going to be hard for me to stand here. I'm a bit of a wanderer when I talk normally, but I'll do my best to stand here because this is where the microphone is. I'm going to talk to you about ImmuneDEX today. So part of our job is to develop new traits for the animal production system. Oh, okay. Then I have the issue of having to use both hands now. ImmuneDEX. So this is basically a health trait. It's a generalised disease resilience trait. What ImmuneDEX is making cattle bulletproof. What ImmuneDEX is ensuring that cattle have a functional immune system, and it basically positions them so that they can deal with whatever challenge that we throw at them. As we've already heard this morning, one of the options for breeding for disease resistance is to target specific diseases. But what we wanted to do here was come up with a generalised one. So something that would be useful for any disease or infectious challenge an animal faced in its life. A couple of thank yous. I'll do that up front. I'd like to thank the organisers for inviting me. It's a great opportunity for us to come and present the work, and also to thank the team of individuals of both CSIRO and Angus Australia staff who have contributed to this project over about 10 years now. And as you'll see, I'm wearing my ImmuneDEX shirt today. We're very proud of this shirt. It might look like it's just come out of the box and I've never done a day's work, but that's not true, I can assure you. So as I said, ImmuneDEX is about 10 years old. People have probably seen this work presented before, and Brad Hine is normally the person who comes and presents that work. Brad's a bit tied up at the moment, so he said, Aaron, you go and present the work, and he assures you that you're in good hands. So before we begin, we probably need a little bit of background. So this is university immunology on the slide. So animals respond to infection. People probably have a bit of a rough idea about that. Everyone's an immunology expert these days after COVID. So it doesn't matter whether it's a virus or a bacteria or a parasite or an insect, whatever it happens to be. If it gets into your body detects it, and it starts to mount a response that's appropriate for getting rid of it. And you'll see there's two basic types of response we talk about here. A type 1 response, which is really good for getting rid of things like viruses, and a type 2 response, which is really good at getting things like worms and ticks. The type 1 response is characterised by all your white blood cells getting pretty excited and proliferating and starting to kill things. And a type 2 response is characterised by producing heaps of antibody. So that's important to remember as we go forward in the talk. So as I mentioned, part of our interest here as well was not making animals sick. Producers tend to get pretty unhappy if you come up to them and say, we can identify an animal that's disease resistant, but first of all we have to infect your animals and maybe some of them will die. So that's a difficult conversation to have. So we thought, well, how else can we do this? So we thought, well, let's look at response to vaccination as a proxy for infection. It's doing all the same things to your immune system, and it comes with the benefit that it doesn't make your animals sick. So we use UltraVac. We could have picked any vaccine really, but we chose that one, partly because it has quite a few different antigens in, so it ensures that it's just not some sort of antigen-specific response that we're looking at. And we look at the cellular response and the antibody response after we vaccinate the cattle. The reason we look at both of these things is because if we select for a particular disease, you tend to bias it one way or the other. And so what we don't want to do is bias the response. We want to make sure that both arms of the immune response are there and that they're available should an animal have to fight a virus and a worm in its lifetime. So we've done lots of measurement of this over the last 10 years, this trait. So you can see here, this is just plotting out all the different records. So these were the top ones, were the records collected in 2012 and more recently collected in 2022. Beyond our statistics software getting a bit fancier over that time, the distributions are pretty much the same. You can see the cellular response is a tighter distribution than the antibody response. Quite concerningly for us, you'll see that there's animals that almost have a zero antibody response, and that means even if you're vaccinating those animals, they're not really triggering them up to a protected state. And so that was a bit of a worry, and we wanted to sort of dig into that a little bit more. So after we collect all of these phenotypes, we pass them over to Tony and the team over here, and they weave their magic and they turn them into all of these numbers like Jono just showed. On the Diagonal axis there is the heritability of the trait, which basically is how much the genetics explains of the trait. The important take-home message here, if you look at the boxed areas over here, are the negatives and the positives. So there are negative correlations to the growth and production traits and immune competence. And again, this is an important part of the story that I'll go into a little bit later. There's favourable relationships with temperament traits. I should probably point out as well at this stage that even though it's a negative correlation, it doesn't mean that you can't have both. It just means it's a little bit harder to do that. So these are the numbers of cattle that we've tested over the last 10 years. The current research breeding value is based on the records up to 2018. We have a whole heap of records that continue on into this year. It's probably time that we update that. We can just about double the number of animals that are included in that SNP effects equation once we do that. So with the support of MLA, we did a trial to actually show that, okay, we can collect the trait, we can measure the trait, we can work out how the trait links to a whole range of things, but does it actually have any benefit to animals that have the immune competence trait? So what we did was we tested a whole heap of animals and we ranked them as high, medium or low, and we sent them through a feedlot production system, and we looked at the health costs associated with those animals. So you can see here that animals that were categorised as high immune competence had an average of $3 per head health costs for the time that they were in a feedlot. Average animals, 28, low animals, $103. So that's a pretty big difference. When we sort of broke the information down even more, it became clear that the bottom 10% of animals, they're the ones that are causing all the problems. 35% of the health costs are there. But beyond that, these are the animals that bring disease into your herd. These are the animals that allow disease to persist in your herd. So identifying these animals and getting rid of them is a pretty important part of the process going forward. We're not suggesting that everyone should be trying to push for high animals. We definitely think the selection pressure should be applied to the bottom end, getting rid of low ones, because that's the problem. So again, with the support of MLA, we've repeated this work just recently. It wasn't quite as beautiful this time around. I can provide the excuse that this was from 2019 into 2020, so we had some really weird weather conditions, and the cattle that did die that were high immune competence died of something that the feedlot called wet weather disease. You won't find that in a textbook, but we included it in our system anyway. We didn't want to be leaving anything out. I think this quite clearly shows, though, that you don't necessarily have to be the best animal, but what you don't want to be is the worst animal. Again, all the health costs are in the bottom end of the distribution down here. Quite a high proportion of those animals die, and that's obviously a massive production loss. If you're bringing an animal into the system, if you're feeding that animal for a number of days and then it drops dead, you're obviously getting no money for that. They also have a much higher pull rate and treatment rate in the system. And at about $50 for an injection of antibiotic to treat them, that's a pretty costly process. Now, I've put the little bit over here, resource allocation theory, on, because this is the bit where I mentioned that you don't need to be the best, and also explains the negative correlations. And it basically comes down to the fact that there's only so much energy in the system, and you can choose what you put that energy into. You can put it into growth, you can put it into mounting an immune response, you can put it into reproductive activities. If you have to do all of those things, it has to be shared across all of those things. So you don't want to be necessarily a super high immune responder because there's going to be an energetic cost associated with that. But you don't want to be putting all of your energy just into production traits, otherwise you end up down the bottom down here. And that's fine in a world where we can use drenches and chemicals and antibiotics to mask these animals in the system, and that's pretty much what's been happening over the last, say, 30 years. But in a world where people are regulating against those approaches, in a world where those treatments are becoming less effective because of the resistance of the parasites themselves, this is where you need an effective immune system to deal with it. So when we have an EBV, basically we have this SNP effects equation, which allows us to give an immune competence score to all animals that have a genotype. So what Christian and the team did was go back and apply that right across all Angus animals that have been genotyped. And this chart actually goes back into the 1960s with that. But what you can see here is the concerning trend of ImmuneDEX is trending down. So as Christian showed before, all the productivity traits are trending up, and that's where all the energy in the system's going. But that comes at a cost because you can't run an immune system anymore. So we've got to find the sweet spot where we've got the best of both worlds. The 1960s animal is even higher up, so this has been a downward trend that whole time. It's really impressive to see it. Where that difference is coming from is largely in the antibody response. The cellular response seems pretty much stable. The antibody response has been going down and going down significantly. And I think it was really timely that we did this work when we did, because if you kept doing this for another 20 or 30 years, you potentially crash the system. But we've identified it now. If people incorporate it into selection indexes, we can turn the corner. And as I said, we don't necessarily have to have it skyrocketing upwards, but we just want to make sure it flattens out and doesn't keep going down. So I just wanted to finish up with some really exciting results. And, you know, we think of ourselves as animal scientists and animal producers and all the rest of it. But what we actually have here is a data set that is hugely significant to medical science generally. So what we can do is this thing called a genome-wide association study, and it basically tells us the genes that are associated with this trait. So this fancy picture on the side over here shows you chromosomal regions where we've had some hits. So we've identified the genes that control the antibody response in cattle with enormously high significance. So when Tony gets excited, I get excited. So he tells me this is real and this is something that we should be pretty enthused about. But what we have here at a functional level is we have the genes that can tell the body to produce more antibody or less antibody. We have the genes that tell the body to produce more white blood cells or less white blood cells. Cows are mammals, the same as us, same as all other sort of mammal production species. This isn't just relevant to us, this is relevant to everyone. And so we're actually having a really good look at this at the moment because we think this is potentially an enormously valuable outcome. Pharmaceutical companies get pretty interested in stuff that can pump immune systems up or down, and we have a unique data set here that tells us what those candidates are. Even in CSIRO, I have a hard time convincing them that us lowly animal scientists actually discovered this. They go, oh, surely the humans have got this already, they must have all of this same data. I can assure you it doesn't exist. So we're trying to work out what exactly to do with this and how to maximise it. And then going on from that, just with the immune competence trait generally, so we've done it for Angus, but now the other breeds have picked up on this and the value of it, so they're starting to do it as well. Sheep are starting to do it as well. And when I was a group leader, I also looked after all of the aquaculture stuff. So the salmon industry want to do it and the prawns want to do it. So I think everyone can feel pretty proud that we've started a really big ball rolling across all of the animal production systems here. It's started here in Australia and it's something that's going worldwide. So that's something we can all be very proud of, I think. Just finish with an ad finally. So just some other work that we're doing. So we've had this immune stimulant we've had in mind for a long time, which potentially you can give to cattle in a feedlot. The idea is that it closes the window between an animal getting vaccinated on entry into a feedlot and before that vaccine kicks in. It's an antibiotic alternative, so it's not an antibiotic. We've got the money to test this. We now have APVMA approval to run the trials. So if there's any feedlot operators out there that are interested in working with us to test this agent, I'd be really keen to talk to you about that. I know Brad has already talked to some people, but yeah, we just need to pick up on those conversations now because we can actually do it now. And so just finish off by identifying this high responder again over here. And thanks to all of our staff. It is a huge exercise for our staff. I mean, they literally travel from Victoria through to North Queensland collecting these samples, and often they'll have to drop blood samples off. I've got all these photos of them sitting in motel rooms with centrifuges spinning blood. If you find weird stains in, some country motel, it probably got there through good causes, not bad. So just remember that. A huge thanks to Angus Australia and Christian and the team for supporting us over all this time. It has been a 10-year exercise and it's grown into lots of other things. The cooperator herd owners, we've had fantastic cooperation from the producers out there to collect this data set, and that's been fantastic. And of course MLA for allowing us to do the validation work to show that there was something worth collecting here. So thank you.